Greetings, geometry students. Today we are going to take a deeper look at the angles that are formed around transversals. So please copy down today's title, which is Angle Relationships Around Parallel Lines. After copying your title, also copy down the objectives. And our stated objective for today is the student will learn the relationships within the angle pairs around a transversal. Now, this will not be the first time that we have seen angle pairs this year. We've also talked about some other types of angle pairs, things like vertical angles and linear pairs and things like that. So this will just be adding into that vocabulary. The language objective, which you do not have to copy, is the student will demonstrate the ability to solve for unknown angles around parallel lines and transversals. When it comes down to benchmark tests and semester tests and things of that like, there are always questions that come from this particular unit, so it's important to understand exactly what's going on today. And the essential question for today is, can I solve for unknown angles around parallel lines? Well, the critical thing for being able to solve for unknown angles around parallel lines is to know what kind of angles you are actually looking at and what should the measurements of those angles actually be doing. As always, anytime you need more time, simply press pause and then hit play when you are ready to move on. Okay, here's a new term for us. When a transversal, okay, and we're going to start off with a transversal. You'll see more about what a transversal is here in a moment, but that's where he is going to be positioned within our diagram. When it intersects two parallel lines. Okay, so we already saw yesterday that we had a transversal. Transversal was a line that intersects two or more lines, which you can see our transversal is intersecting two or more lines in this instance. But today we're going to be focused on what happens with the angles when those lines are parallel to each other. Now, when a transversal intersects two parallel lines, the angles that are formed, and as we saw yesterday, there are 8 of them around these two intersections. And today we are focusing on the various properties that are going to arise involving these 8 angles simply because those lines are parallel. Okay, now the key to the information that we are about to go into is you absolutely, positively, 100% of the time must verify that the lines that you are intersecting with your transversal are in fact parallel to each other. If the lines are not parallel to each other, you will not apply any of the 4 rules that we're getting ready to look at today. Okay, so let's take a look at the first type of angle pairs. Okay, now these are all going to be written in conditional format, so please pay attention to that. If two parallel lines are intersected by a transversal. Okay, so that's a critical word, if, right there, because if the lines are not parallel, we are not going to worry about this rule at all. If two parallel lines are intersected by a transversal, then your corresponding angles, wherever they may be, are going to be congruent. Now remember that the word congruent simply means equal measurement. Okay, so let's take a look at what this will look like in a diagram. We're going to use this same diagram over and over again, so you can spare yourself having to copy it down each and every time. Go ahead and get it copied down if for some reason you did not get it on the previous page. If you've already got it, don't worry about it. Again, we're simply going to talk about it over and over again. The rule says if two parallel lines are intersected by a transversal, then corresponding angles are going to be congruent. Okay, so the first thing we are checking on in the hypothesis of the statement is if we have two parallel lines. Well, we did verify. We can see there in the diagram by the red arrows that we do have two parallel lines. That means this rule applies, and the rule says that anywhere we have corresponding angles, they will be congruent. So looking into the diagram, well, we can see, remember, corresponding means they're at the same basic positioning, but at different intersections. So in this case, angle 1 and angle 5, they are corresponding angles. They are both up and to the left from their respective intersections. So this rule guarantees that angle 1 and angle 5 are going to be congruent. Now, obviously, those aren't the only pair of corresponding angles that are in the diagram. We could have just as easily picked on angle 2 and angle 6, which are up and to the right from their respective intersections, and we could state that they are congruent as well. Similarly, the argument could have been made for angle 3 and angle 7 being congruent because, once again, they are corresponding angles around parallel lines. And lastly, of course, angle 4 and angle 8 could be stated as well. They are congruent because they are corresponding angles and the lines are parallel. Okay, the second type of angle pair that we're going to look at is going to be our alternate interior angles. Okay, and these rules are going to start off very similarly in all cases if two parallel lines are intersected by a transversal. That language is going to be common for all four of our rules. And the conclusion in this case will be that your alternate interior angles are going to be congruent. Okay, so there's that same diagram once more. Again, you don't have to copy it down if you already have it, but let's take a look at what happens inside of the diagram. Okay, we have to check the hypothesis. If the lines are parallel, we look into the diagram and we see that yes, they are parallel. Then the rule states that your alternate interior angles are going to be congruent. So looking into the diagram, we can find alternate interior angles at angle 3 and angle 6. Those are alternate interior angles. The lines are parallel, so this rule guarantees that angle 3 and angle 6 are going to be congruent. But of course, those are not the only pair of alternate interior angles in the diagram. We could have just as easily selected angle 4 and angle 5. And again, this rule will guarantee that angle 4 and angle 5 are congruent because they're alternate interior angles and the lines are parallel. Those are the only pairs of alternate interior angles that are to be found in the diagram. Okay, next rule is going to start off with the same language once more. If two parallel lines are intersected by a transversal, this time we'll be dealing with the same side interior angles, and the rule guarantees that same side interior angles will be supplementary. Hopefully you remember from Unit 1, the term supplementary means two or more angles that add to equal 180 degrees. So again, using the same diagram from before, since the two lines are parallel, and again, that's part of our hypothesis, you have to verify that that condition does apply before you can let this theorem try to help you with your problem. Okay, looking for some same side interior angles. Well, angle 3 and angle 5 are same side interior angles. And since the lines are parallel, this rule guarantees us that angle 3 and angle 5 are supplementary. Those are not the only pair of same side interior angles. Obviously, we could have also looked at angle 4 and angle 6. And this theorem guarantees us that since the lines are parallel, angle 4 and angle 6 are also supplementary. And the final rule, once again, same hypothesis. If two parallel lines are intersected by a transversal, then your alternate exterior angles will be congruent. All right, so one last time using the same diagram. Since the two lines are parallel, and again, that's your hypothesis. You have to verify that in the diagram every single time before you use any of these rules. If you can verify that, then you can apply the rule. And in this particular case, the rule guarantees that alternate exterior angles are going to be congruent. Now, looking into the diagram, we can find a pair of alternate exterior angles at angle 1 and angle 8. This theorem guarantees us that angle 1 and angle 8 will be congruent since they are alternate exterior angles and the lines are parallel. But once more, those aren't the only pair of alternate exterior angles in the picture. We could have just as easily said angle 2 and angle 7. And the theorem does guarantee us that angle 2 and angle 7 are going to be congruent as well. And those are the only pairs of alternate exterior angles that are in the diagram. Now, if you were paying attention through all of that, you notice that there are 4 different types of angle pairs. 3 of them guaranteed that they would be congruent. There was only one that was not congruent, and that one was supplementary. And if you remember which one was the one that was supplementary, it was the same side interior angles. So an easy way to try to remember which of the 4 is the one that is supplementary, it is same side interior, same side. Both of those words start with S. Supplementary also starts with S. So if you can just kind of put all the S's together, same side supplementary, that should be an easy way to help you remember which one is supplementary, and then the other 3 types are actually going to be congruent. Okay, so let's take a look at how this is going to all interact in a diagram with each other. Okay, so look at an example. Here is a basic diagram. Okay, probably much easier than we can expect to hope for in any problem that will end up working on a test or anything like that. But we're just starting off with an easy one because I want to make a few points to you. Okay, I'm going to demonstrate several things here graphically, so you don't necessarily need to copy this particular part of this example down, but definitely follow along with me here. Okay, when you look at the 2 types of angles that you have, well, first thing, please notice that the lines are parallel. Okay, so the lines are parallel. That means that we have new rules that we can use to spread the information throughout the diagram. We can apply corresponding angles. We can apply alternate exterior angles. We can apply things like that as long as these particular angles apply in the from the diagram to the rules that we have. Now, we wouldn't want to pick on necessarily any interior rules because neither of these angles are on the interior. Okay, but we have parallel lines, so we can use any rule that we want from those 4, and also never lose sight of any old rules that we have already covered in previous units. Those things are always fair game to show back up at any time. Okay, so let's see what we can do as far as relating these angles. Okay, so the first thing you might notice is that of the 4 angles, 4 types of angle pairs that we have, these 2 angles do not apply to any 4 of the angle types. Technically, if we wanted to put a name to these guys, we would call them same side exterior angles, and we have no rule to accompany same side exterior angles, so we're going to have to make some adjustments. Okay, one of the things that you could do, and again, you don't have to copy this down, just follow along with me. Okay, you could use the idea of corresponding angles to move one angle over to the other intersection. Remember, corresponding angles are at the same position at different intersections. So we could conceivably move the 110 degrees to the corresponding position at the other intersection. How would that help us? Because we could then have a linear pair with the two angles that now exist, and we know that a linear pair add up to 180 degrees. They are supplementary. We'd be able to add 110 plus x and let it equal 180, and then we could solve for x. That's one possibility. Another possibility is you could use a rule like alternate exterior angles. Okay, using alternate exterior angles, we could move one of these angles to the other intersection using the alternate exterior angles rule, and then once again, we would have a situation where a linear pair would be established, and then we could add the two angles up to have them equal 180 degrees. That's another option. Yet another option would be the idea of allowing vertical angles to come into play. We could move one of these angles through its intersection across from itself, and then you could use one of the rules that we have, maybe alternate interior angles. And then once again, then you have your linear pair set up, and they could be added up to equal 180 degrees. Or possibly use the vertical angle rules twice. Move both of the angles through their respective intersections. And then you would have same side interior angles set up. Okay, and once again, same side interior angles are supplementary. They would add up to equal 180 degrees. Okay, so what I think you're seeing here is that there are a lot of different ways to relate these two angles, and you're going to see that in geometry quite a bit. The more you learn about geometry, the more ways there are to solve any given problem. Okay, but in all of the cases that we just saw, no matter which rule we tried to apply, we saw that this particular diagram, the two angles in this case are supplemental. So go ahead and write that down. And of course, supplemental means they are going to add together to equal 180 degrees. So that's what we said every step of the way. 110 plus x should equal 180. And then all you have to do is solve for x. So we'd get all the way down to step 3 before we had anything to do, which would be to isolate or move everything away from the x value. Actually, it'd be step 4. Subtract 110 from both sides, and obviously x is 70 degrees. So that's a very basic example of how these rules work. So let's look at one that's a little bit more along the speed that we're going to have to be doing. Okay, so let's try this one. Most of the time with these type of problems, you're going to have multiple variables or multiple instances of a variable inside of the problem. So copy this guy down, and then let's see what we can figure out about it. Okay, there are two very important questions that always have to be answered before diving into a problem like this. Is first off, are the lines parallel or not? Because if they're not parallel, we don't want to try to use any of these rules. Okay, so obviously we can verify that they are parallel by the little parallel arrows. And the second thing is, are these any particular type of angles that we know about, or are we going to have to do some fancy moving some stuff around like we did on the previous screen? Okay, well, these particular types of angles that we are looking at here, these guys are alternate exterior angles, pardon me. Okay, so now you got to ask yourself, all right, the lines are parallel, the angles are alternate exterior. Is there any kind of rule that goes along with those two guys? And the answer is yes. Alternate exterior angles are supposed to be congruent. Congruent means they are equal to each other, so that is our equation. Whatever 2x plus 8 is, and whatever 3x minus 3 is, they are equal to each other. Now we have a very simple linear equation, and we need to solve it. Step 3 of the solving equations procedure will have you looking at moving your variables one direction or the other. It would be best, I think, to move the x's to the right side of the problem, although you could go to the left if you wanted to, but I would subtract 2x from both sides. That would leave you only the constant 8 on the left and x minus 3 on the right. Step 4 would be to move everything away from your variables so that minus 3 does not need to be there. So we could add 3 to both sides of the problem. And obviously, x is 11. Now you can check your work by plugging back into the equation, but remember the hazard with writing your own equation is if you wrote the wrong equation, all you have is an answer that matches your equation. So you got to be very careful to make sure you get the correct equation written down. Let's look at one more example real quick. Okay, same set of questions is going to exist as you enter into this problem. First off, and most importantly, are the lines parallel? Because if they are not, we cannot use these rules. The lines are parallel, so then we go, all right, what type of angles do we have here? Are they any special kind that we know about? And in this case, the answer is yes, these are same side interior angles. So then your brain needs to go, all right, what do I know about same side interior angles? And hopefully your brain goes, same side interior angles are supposed to be supplementary. That means whatever 2x plus 8 is and whatever 3x minus 3 is, they are supposed to add together to equal 180 degrees. Remember, all the s's go together, same side supplementary, same side supplementary. Okay, walking through your 5 steps of solving an equation, we would get to step 2 and see that we have some like terms that can be combined. On the left side, we have 2x's and we have 3x's. That is 5x's. Then we have 8 constants and negative 3 constants. They can combine to make 5 constants. So our equation now says 5x plus 5 equals 180. You would get now to step 4 of moving everything away from your variable, and that positive 5 does not need to be there, so we would subtract 5 from both sides of the problem. That would leave you 5x equals 175. And then lastly, we want our 1 and 1 for our coefficient and our variable. Currently, we have 5 x's. We do not want 5 x's. We only want 1. So to move the 5 but leave the x, they are currently being multiplied. The opposite of multiplication is division. So we would divide both sides by 5, and that would leave us x equals 35. The problem is solved. We can plug it back in to see if that is the correct answer, but again, all this answer is doing is matching up with the equation. If we wrote the wrong equation to begin with, then we will have the wrong answer, even though it checks out. Okay, lastly, jot down a summary real quick. Note any questions that you may have, and as always, keep the essential question in the back of your mind. Can I solve for unknown angles around parallel lines? I apologize for the little bit lengthy video today, and I will see you in class.